Okay, in this video, I'm going to show you how we can use a graphics calculator to do normal distribution problems in reverse, or what we often call an inverse normal distribution problem. And in this case, what's happening is the proportion or the probability or even the percentage is given to you for a certain situation, and then you need to calculate the corresponding value on the x-axis. So I've got a picture here where you can see along our x-axis down the bottom, we've got a question mark. We don't know what this number is. We've been told what the mean and the standard deviation are. Mean in this case is going to be 0 and the standard deviation is 1. But we are told that this area is 20%. Okay, we don't know what that number is, but we know that 20% of these things are less down here, less than that number. So the way that we calculate this number is we're going to go into our graphics calculator again. We'll go to stats, just like yesterday. And you'd go into distributions, F5. You go into normal, F1. And then you'd go into inverse normal, this one, okay? INVN, inverse normal. So that's F3. Now, if your one shows up the top here, data list, then you need to switch that so it says data variable, and you'd push F2. If it's already got data variable, then you're all good. And what you should see is an option to switch your tail, an option for the area, an option for sigma, our standard deviation, and an option for the mean as well. So for this question, let's go through and put all the numbers in. We're going to have a mean of 0 and a standard deviation of 1. Well, they're already set up for us, which is great. Now, the area is the shaded in part that we're looking at here on the left-hand side. And so we're going to put in an area, and that needs to be as a decimal. We're going to put in 0.2 for that. All right, so not 20%, but 0.2. And then, so make it a decimal, and then the tail, you'll see this tail here, this area that's shaded in is on the left-hand side. So our tail is going to be the left. Okay, you'll notice we've got some options here, left, right, or center. We're on the left at this point. Once we've got all that information in, we just push execute, and it gives us a number. So the X value, this question mark value on this one is negative 0.8416. Okay, and you can round that appropriately depending on the situation. In this situation, there's no sort of context, there's no story, so we'll just use our rule of thumb and round that off to 4 dp. All right, we'll move on to the next question. This one has again got the same mean and standard deviation, so I will exit from here, check that my mean and standard deviation are what I want. I'll change my area this time. It was given to us as a decimal, which is nice. And we're going to make that 0.04 for the area. And this time it's on the right-hand tail. So we're going to change the tail to the right, which would be F2 there. Switch that to right and then execute. And that'll tell us a number. So this time our value here is 1.7507. If we round that off. Okay, so before, because it was on the left-hand side, it was less than our mean of 0, so it had to be a negative number. This time it's on the right-hand side, it's more than 0, so it's going to be positive. All right, the last kind of shape that you can get is one like this, where it's equal on both sides. And what's happening now is our area is in the center. And notice we've got a positive value of Z, whatever Z might be, and a negative value of Z, which is, so they're both the same number, it's just one's positive, one's negative. They're both are centered on our mean. All right, so we're going to exit from there, check that our mean and standard deviation are what that says, so that's good. Our area, all right, now this time the area is not in there. Let's suppose that the area is, let's say it was 40%, okay? So when I made this worksheet, I forgot to actually write in the area on there. But let's say that was, actually looks a bit like more than 40%. Let's say it was 60%, okay? So the area looks like it's about 60. So let's put in an area of 0.6 for 60%. Okay, my bad that I didn't write it in on the little sheet that I made. So 60%, 0.6. Execute that. But our tail, instead of being on the tail, is actually in the middle. It's in the center. So we're going to switch that to center, F3, and push execute. And now it tells me the upper value and the lower value. So negative 0.8416 for down here and positive 0.8416 for up there. Notice they're both the same number as you'd expect, just one's a negative, one's positive, because they're either side of 0. If my mean wasn't 0, then these would be two different numbers, but they would be exactly the same amount from on either side of whatever that mean number was. Okay, so just watch that carefully when you put those in. Now, there's one more type of question, and that is if we've actually got a story to go with it. So I'm going to show you that now. Here's a question with a story to go with it. And I'll just put my calculator over on this side and move me out of the way. Here we go. So we've got the diameter of sunflowers for sale at the supermarket is normally distributed with a mean of 13 centimeters and a standard deviation of 1.5. So I think the first thing I'll do, is put in the mean and standard deviation. So I'll do that before I forget. Standard deviation 1.5, and the mean value was 13. So we'll put those in. Now the question says the largest 15% of sunflowers get put at the front of the display. Okay, so people can see, oh, look at those beautiful sunflowers. What is the minimum length of a sunflower that gets selected for going on display? All right, so I'm just going to focus on this screen for a bit and add a little bit to my drawing. So there's 15%, and they're the largest ones. So they're on this end of the distribution, this right-hand end, because they're the big ones. All right, not this end because they're not the smaller ones. We'd have our mean right down the middle of 13. So that would go down there. That's 13. And then we would also have this unknown value somewhere up around about here, where we've got 15% in this area up there. So I'll put that in as well. I'm going to put in a number that says 15%, or actually let's put that as a decimal since that's what's going to go on the calculator. 0.15, that's in that space in there. Okay, I'll just get rid of these things out of the way. So there we go, 15% is going in that space there. So what's the length? Well, the minimum length would be whatever values at this line here. Anything that length and more is going to go on display. So that's my question mark, is what number's there. Remember, that's 13, that's the mean, but what's this one? It's going to be something a bit more than 13, obviously. So let's bring up the calculator again. Okay. And we're going to go into the area is going to be 0.15. That's our shaded part. Whoopsies, wrong button. And then our tail is on the right-hand side over here, not the left and not in the middle. It's on the right. So F2, we'll switch that. And then we'll push execute. And it's telling me that it's 14.56. Let's round that off to 14.6 centimeters is the number that's going to go there. The minimum length for a sunflower to get picked to put on display. All right, so that is how you use your graphics calculator to do normal distribution problems. Hopefully that all makes sense.